In this lesson, we've got a lot of ground to cover. We're going to talk about object-oriented programming fundamentals in C#. Now, C# is an object-oriented programming language. Object-oriented programming is a mindset, or rather a philosophy of programming, that attempts to simplify the creation of complex applications by relating things in code to their counterparts in the real world. Now, when you first get started with object-oriented programming, or sometimes it's shortened to OOP, O-O-P, or just O-O, you might think that it really doesn't simplify anything. It makes a lot of things more difficult. Now, in simple applications, that might be true, but as applications grow and the changes are required by your management or by your users, by applying these concepts of OO to your applications, it makes them more flexible and less easily broken. There's a lot of advantages, and I'll try to point out a few of them in this lesson to using object-oriented programming. But like most of the topics that I've introduced in this series of lessons, I'm really going to only scratch the surface. It could take months or even years of working with OO to fully understand it and apply it to your applications. Now, if that's true, you might be saying, hey, why are you introducing this so early? It's only lesson 6. Well, the reason is because OO is all around you, whether you realize it up to this point or not. In the first lesson, you were writing object-oriented code, and you never even realized it. C# is object-oriented, and as you'll see in this lesson, you have to understand OO to be somewhat productive in C#. Now, admittedly, you might not be to the point where you can fully harness the power of OO yet, but in my opinion, it's never too early to introduce the basics because it's going to make a lot of things easier to understand after this lesson. So let's get started by talking about classes. And the basic building block of object-oriented programming is a class. And you can think of a class as a blueprint of perhaps how to build a house. Or think of it as a recipe that explains how to create a batch of chocolate chip cookies. Or think of it as sheet music that someone can perform. In fact, lots of musical groups can perform the same piece of music. In each of these cases, there's a distinction to be made. The blueprint is not a house. The recipe is not a cookie, and the sheet music is not a performance. They define how each of these should be performed or built, but it's not the same thing. You can create several houses from the same blueprint, and each of the house is an instance of the blueprint. The color of the brick, the walls, the carpet, they might be different in terms of color or whatever the case might be, but they're essentially the same house. And you can create multiple batches of cookies from the same recipe. Now, each cookie might be shaped a little bit differently. Some might be bigger than others and smaller, but there's no denying that they're all cookies that were created from the same recipe. And many different musicians can perform the same piece of music. Each sounds just a little bit different, but there's no denying that essentially they are the same song. So that's in essence the difference between what a class and an object is. A class is a blueprint, and an object is an instance of that blueprint. You can create several instances of a class. Each instance is undeniably created from the class's instructions, and each object instance can have different properties or different values for their properties, but they're still from the same class. Let's take a button for a concrete example that we've been using in our lessons. Now, I can have two buttons on my form. One can be small and gray, and the other one can be big and red. But they're both buttons. It's just that each instance of the button has different properties. Now, do you realize the button in the toolbox is essentially a class? And each time we drag it from the toolbox to the designer surface, that we're creating a new instance of that class. We can change the properties of each of the buttons independently of each other to make them appear differently, one big, one small, one red, one gray, but they're both instances of the same button class. Now take a look at the source code that defines a form. A form is a class in C#, and when our application is run, an instance of our form is created. You see, object-oriented programming is all around you. You've already been working with it. You just didn't realize that that's what it was. In the remainder of this video, we're going to look at how to create and use our own classes and objects in our applications. We're going to move pretty fast, but we'll still try to take everything one step at a time. And I encourage you to also read through the document that accompanies these videos to learn more about programming with classes. So let's get started by creating a new project. We're going to call it lesson06, and let's just drag open our toolbox and do what we normally do, put a little button on our form. Now what I want to do is add a new file to my project. So I'm going to select Add, New Item. I'm going to select Class, and I want to call the class, for our example, Car. Okay, so we've created a class file, and whenever we create a class file, it automatically will create this class car with a code block defined underneath it with curly braces by default. It's a very simple class. It doesn't really do anything. It's empty right now, so it's a pretty boring example, but we've defined a class nonetheless. So now let's go to our form, our button click event, and let's add some code here that will create an instance of our car class. So if we ran the application right now, nothing would happen just yet. But this gives me a chance to talk about the practical side of defining a class and creating an instance of that class. Now I could perform these two lines of code that you see here where I've defined, just like I would any variable, a new variable called myCar. It's of type car. So we are creating types, data types, whenever we are creating classes, and we can create instances of those types or classes the same way that we would create an instance of a string or an integer, for example. Now there's the second line of code. We could actually do this all in one line, like so. Let's do this. Car, my car equals new car. And this might look very familiar to what we did in the previous example where we did something like this to create an array. String my array equals new string like 2. Do you remember that from the previous lesson? So at that point we said we would talk about the new keyword, and that's what we're going to do right now. The new keyword does two things. First of all, it creates a spot in the computer's memory for our object based on its data type, which is the name of its class. So in this case, we're creating a spot in memory for a car. Now the next thing that it does is that it grabs the memory address that holds our object, and it assigns that address to the variable name myCar in this case. So myCar is really just holding a pointer to a spot in memory, just an address, to the object in the computer's memory. Now what we could do is this. Let's go ahead and get rid of this line of code here and just talk about this for a moment. Let's comment this line of code out. And so we're essentially creating or defining a variable, a container to hold an address, but if we fail to use the new keyword, we're never assigning an address for myCar to actually hold. So whenever we try to use this object, myCar, we'd probably get an exception from C# that said something like object reference not found or something along those lines. Because although we've created the container that holds a memory address, we've never assigned it. So whenever we try to use that, it's going to say, well, I don't know what to point to. There's nothing, you've never told me where in memory to point the myCar variable to. So hopefully that's a distinction that will help you if you forget to use the new keyword and you get this exception about object reference not found or a reference missing or something along those lines, that's the reason why you would get that. So let's continue on. Now at this point our class really doesn't do anything meaningful, so we need to add something to it. Now let's consider the button class for just a moment. We were able to drag the button class from our toolbox and drop it on our design service, which created an instance of the button class, a button1 object. And in order to change this instance of this object, to change its appearance or behavior, what we did was go over to the properties. For example, we could change the text property, which would change what it says, and we could change the type of font that we use to make it look different on the face of the typeface that's used. So the principle here is that we can modify properties of an object instance in order to modify the way that that particular instance appears or behaves. And when we create our classes, we can add properties that allow other parts of code to change the way that our classes behave or how they appear or how they work internally. So we want to add the concept of properties to our classes. There are two parts to a property. First of all, there's a variable that maintains the value of the property, and that's called a field. And then there are methods that allow for the accessing of that field's value. And those are called properties, get and set. Okay, there are two distinct parts. There's the part that holds the value, and then there are the parts that allow you to access that value. And that's an important distinction to make, as you'll see here in just a moment. So what we're going to do is turn over here to our car class again, and we're going to make a little space and paste in some code. And let's scroll to the top of this, and you can see we have two distinctions. First of all, a set of 3 lines of code that are our fields, and then the remaining chunk of code that I pasted in are the properties. As you can see, I've defined a field much in the same way that I've defined a variable in the previous lessons. Now the biggest difference is this use of the keyword private, and I'll explain what the term private means a little bit later in this series of lessons. But you can see here that I've defined 3 variables, or 3 fields rather: string underscore make, string underscore model, int underscore elapsed mileage. And in each case, notice that I have an underscore and then a lowercase letter. Now that is a special nomenclature that I chose to use. You are not forced to do that by C#. When we get to the end of this series of lessons, when we start creating our RSS application, we'll talk about how to name the values, the variables and classes and things of that nature, and how to choose a naming convention that helps you visually see what that thing is doing within your code, whether it's a field or a property or a class or whatever the case might be. Now there's no right or wrong way to name. There's some standard ways that people have adopted, but you don't have to follow that convention. That's just something that I've done, and I think it's a good habit to get into. But let's move on and not talk about that too much more. Let's move on to talk about the next section of code, which is properties. You can see here that I've defined 3 properties: a public string make, public string model, and public integer elapsed mileage. And again, for now, let's just ignore the use of the keyword public, just like we ignore the keyword private earlier. I'm going to talk about them at length a little bit further on in the lesson. Just accept that whenever you're defining a field, you should use the keyword private, and you should use the keyword public whenever you're defining a property, at least for the context of this lesson. Now, as we can look at these 3 properties that are defined, make, model, and elapsed mileage, each of the properties have 2 parts defined in a code block. You have a get statement and a set statement. Now, you write code in the get statement. See how the get is similar in all 3 instances, where you have a returning of one of our fields in each case: return make, return model, return underscore elapsed mileage. You use a get statement to return the field value back when it's being requested. And you write code in the set statement to assign that underlying field value to whatever it's being assigned to. So notice the keyword value, it's in blue. This is a generic parameter name that's created automatically for you by C#. And I'm going to talk about parameters in just a moment. Let's come back to this, and at this point just accept this at face value. Let's go back to our button 1 click event. And I'm going to uncomment out this line of code. And I'm going to paste in some more code that will allow us to access and change those properties that we've just defined. Actually, I'll type in the first one. So we have my car dot. And notice whenever I use the period or the dot on my keyboard that I get the IntelliSense that pops up. And I have my properties defined: elapsed mileage, make, and model. So in this case, I want to set the make property equal to, let's say, Oldsmobile. So let's just set a breakpoint here and see what happens when we run through. I'm going to save my application as well. Take this opportunity to do that, accepting the default locations. Now I'm going to run the application. Click my OK button. And then I'm going to begin to use my Step Into button. And let's see how this works. First of all, let's hover our mouse cursor over the property make. currently its value is null. We don't have anything defined in the make property, but we're about to set it to the value of Oldsmobile. So let's step into, you can see here where our cursor is at in the set statement. Currently underscore make is equal to null, and we're going to set it equal to value that's passed in, which is Oldsmobile. And now at this point, whenever I hover my mouse cursor over make, it's set to Oldsmobile. So that's what the set statement does. The set statement simply assigns a value to the properties that we define, and then we have the ability to decide how we want to store those values. In this case, what we did was take the value and put it in one of our private member variables for safekeeping. As you can see, I pasted some more code in here that assign the value for model and elapsed mileage to Cutlass Supreme and 200,000 respectively. Now, just for fun, let's do this. Let's use our trusty message box. In this case, we will show the model of the car. So what are we going to be doing here? Are we going to be setting it? No, we're going to be getting the value that's stored in the model property and able to display that in a message box. So again, let's save and then let's run our application. Whoops, let me do this. Let's stop that. Let's set a breakpoint and then run our application. Okay, here we go. So now let's step into and see that we are in the model property in the get statement, and we are going to return whatever stored in model, in this case Cutlass Supreme, and we're going to return that back to our message box.show statement, which will display it in a message box. Okay, so that's the retrieval using the get statement within a property. Now, classes not only define properties, but they also can define methods. And we've been using methods a lot in the previous 5 lessons, whether we knew it or not. Every time we wrote code inside of an event handler, like our button one click event, we've been writing code inside a method. A method is a named block of code that can be called from another place in our code. These are sometimes called functions or procedures depending on the programming language, but in object-oriented programming, typically the term method is more correct. Now, while a property describes something about an object, you can think of a method as an action that the object can perform. So in terms of a dog, for example, let's talk about a dog class. We might have properties that describe the dog's height, his weight, his breed, and so on. But the dog also has the methods of run and jump and bark. And many times the run, jump, and bark methods depend on the property values of a dog. So if the breed of the property of a dog is a golden retriever, for example, it might run or jump higher than a chihuahua when the property of the dog is chihuahua, for example. So that's kind of a silly example, but I hope that illustrates the difference between properties and methods and how the two can interrelate. So let's transfer that to our car example that we're working on here. We might have a method of our car that's called drive, and perhaps it's based on our car's gas mileage and its tank size, so we can determine how far a given car can travel on one tank of gas. So our drive method might tell us what major city we can drive to on just one tank of gas, and I realize it's a pretty rudimentary example, but I just want to show you the structure of a method. Now, methods can accept what are called parameters, and these are values that will be used in the body of the methods code block to modify how it works. We can use practically as many parameters as we need in our methods, and this is how you define a parameter. Notice that after we have the public int add 2 numbers, I have defined 2 parameters. First I use a data type, and then I use a name for our parameter. And now in the body of the code block that defines that method, notice that I'm able to use the 2 parameters that were defined at the very beginning, first number plus second number. And as you can see from this example, a method can also return a value or not return a value. If a method doesn't return a value when it's finished executing the code block, then it's referred to as a void method. And we use the void keyword in the method's definition. If the method should return a value after it's finished executing, then we would use the data type name when defining the method. In this case, we have public integer, int, add two numbers, int would be the return type that should be expected to be returned from this method. In the case of this second method that we're displaying on the screen, public void display message, notice that we have passed in a parameter, string message, and we're only just showing it in a message box, so it's a very simple method. But the use of the word void means that no value should be expected whenever this method has finished executing. So what does it really mean, though, to return a value? Because we've been talking about this and that may not seem very obvious to you. If the method has been defined in such a way that it's going to return a value, and if you want to use that value in the rest of your application, then you can create a variable that will capture the return value and just save it off for later use. In this case, you see here that I've created an integer called result, and I set result equal to my object dot add two numbers, passing in a 3 and a 5 as the parameters. Now let's say, for example, I were to take that result and I were to try to display it in a message box. What do you think the value would be? It would obviously be 8. Now, I could also use that value result later on in my application within the context of the method. Now, alternately, you can skip that step and just use the method name in the context of another line of code. So in this case, I've just commented out the two lines of code that deal with the result, and instead I've just used messagebox.show myObject.add two numbers, passing in a 3 and a 5, and then I convert it to a string. And in this case, it's just going to go ahead and display the values. So I didn't retrieve, I don't plan on using the result of add two numbers after I show it to the end user. I don't have to save it off in a variable. It just makes my application a little bit smaller. Now, whether you do it one way or the other, that's really up to you. But it's best if you're going to use that value again later on in your code to save it off into its own variable. If not, it's not as crucial that you do that. So now that we have discussed a little bit about the structure of a method and what your options are, whether you are creating one with a return value or you're creating void, how to accept the return value and either save it off or just use it at that point like we did with the messagebox.show. Now that we've done all that, let's go ahead and go back to our car example and add a new method called drive. So here we're going to go to our car example, to our car class, and I'm just going to move below our properties, and I'm going to paste in a method, public string drive. Then I have an open and closing code block curly brace, and I use a switch statement, and I borrow from the make field in order to perform a switch statement and to determine whether to return Chicago, Detroit, or Fort Wayne based on the make of the car. Again, the purpose of this method, fairly straightforward, very simple, and that is to just return back a city that we can drive to on one tank of gas, depending on the make of the car. Okay, again, kind of a cheesy example, but hopefully this will cement in your mind the purpose of and how you create a method. So in this case, I'm going to return a string. You can see it defined here in the definition of our method, string drive. And you can see also there's several return statements. Each return statement will apply based on the case, Oldsmobile, Chevrolet, or the default case. Now let's go over here to our Form 1 button click event and do my car. Now notice that you can see there's a new method called drive that's available. And whenever I call drive, I have to use these parentheses to designate it as a method, as opposed to the use of model here, which doesn't use parentheses because that's just a property. So that's another differentiation that you'll need to be aware of whenever you're calling a method versus calling a property. Okay, let's save it and let's run it. We should expect two message boxes. The first one would be our model, and now based on the make of the car, we get returned back to us the word Chicago. That's the city that our Oldsmobile can travel to on one tank of gas. Okay, again, cheesy. Now, while we're talking about methods, I want to talk about variable scope. Every variable that we define has a scope, and scope means that the variable can only be used within the context of the code block in which it was defined, or any of the subcode blocks that are also defined within the same code block. Now, to illustrate this a number of ways, we're going to add another button to our form. So let's go over here to our design view. Let's go to our toolbox, drag a button. This will be button 2, and I'm going to double click it to get to our button 2 click event. Now, what I want to do, we've already declared a variable called myCar. So should I be able to do this myCar.model? Like, let's just do this. Message box dot show myCar.model. Let's try to run this. You can see we will get an exception. The exception is the name myCar does not exist within the current context. What does that mean? Well, we defined the variable myCar here in our button 1 click event, but due to the fact that this variable is scoped at a method level, it's not accessible to other sibling methods. Now, what if, for example, we were to take this and move it outside of the scope of this code block, and I'm just going to highlight it and watch as I drag and drop it over here, and we'll use the spacing a little bit to make it a little more obvious. So what have I just done? I've taken the definition for the car object that we've defined and moved it outside of the local scope of a method and put it into the scope of our class form1. So we've essentially made this into a field, just like we talked about a moment ago with properties. So we've made a field called myCar. Now what happens if we try to run this application? It works, and there's no complaining by the C# compiler. Why is that? Well, we've defined myCar within the context of the class, and methods are, I guess you would call them, subcode blocks of the class. From a hierarchical standpoint, the class owns the methods, so all the methods can have equal access to this variable that I've defined. Let's illustrate this another way. Let's move down here to our button 2 click and add a selection statement. So here we go. If myCar.make equal to Oldsmobile, then what we'll do is define a new variable, string myModel equals myCar.model. And now we're going to modify our message box to display myModel. Do you think that this will work? Let's try it and find out. Okay, notice that it says that we have an exception, and it says the name myModel doesn't exist within the current context. Well, why is that? Well, because myModel was defined within this code block of this selection statement, but we're referencing myModel outside of the scope of that variable that we created. Now, in order to make this work, what we could do is, just like we did before, is just move it here. Let's go ahead and make some spacing. Now let's try to run our application. And it has a different exception. Let's do that. Now let's run it. Okay, now it seems to work. So what we've been able to do is just illustrate that whenever you're defining a variable, it has a scope. The scope applies to the code block in which it was defined. You can't access any variable outside of its context, of its scope. In this case, we've defined it inside of a code block, and then we moved it outside, and we were able to see it outside of the code block. In the case of my car, we moved it outside of a local scoped method, moved it to a more globally scoped class area, and so we're able to access it throughout the rest of that class. Now, can I access my car from another class? Well, not if it has the private modifier. We'll talk about that in just a moment. So I just wanted to introduce this concept of scope in terms of local variables. Since we're now talking about methods, this gives us kind of the framework to talk about those kinds of things. So let's delete all this. I'm going to actually move this back into place, and we'll just comment all this out for now. And we'll move on from here. And let's continue our discussion of methods, and we've already looked at event handlers as special methods that are executed whenever an event is triggered. For example, our button click events that we have been using throughout our examples up to this point. Now there's another special method that executes whenever a new instance of an object is created. So when the new keyword is used in C#, you can write code in what's called a constructor that will allow you to initialize the instance of the new object. Now, what does it mean to initialize? Well, that really depends on the particular situation. It could mean that you set the field values immediately to some default values, or perhaps it'll check in a file or in a database for some information, or perhaps 100 other things. The use of constructors will become more obvious after you start creating object-oriented applications yourself. But let's take a look at how to define a constructor. Let's go back to our car class, and we're going to move typically to right above our methods, and we'll put a constructor here. And I'm just going to paste in some code. And so as you can see, this is an example of a constructor. Notice we have public car. Now, isn't that the name of our class? Exactly. Whenever you're creating a constructor, it has to be named the same as the name of the class. That's how C# knows that you intend for this to be a method, a constructor method. That's how it knows to call this method whenever the new keyword is used within our application. So let's do this. Let's save this. Let's go back to our form, and I'm going to set a breakpoint whenever we are creating a new instance of our car object and setting it equal to our myCar variable. Let's go ahead and run. Click the OK button. All right, and we're going to use our step into button. Notice that it automatically goes to this new constructor method that we've created, public car. Again, it's automatic because we've used the same name for our method that we used for our class car. Okay? And so here what we're going to do is we're going to make our private fields have default values. We're going to set them to default, and elapsed mileage equals 0. So immediately whenever this instance of this car is created, it's going to have values in it, as opposed to before when those values were just null when we were able to step through previously. So it's going to set the make field to default, the model field to default, and elapsed mileage to 0. And now I'm going to display this in a message box. Notice that I'm using the fully qualified name for the message box object. We'll talk about namespaces in the next lesson, so let's not worry too much about this. Let's just accept it at its face value and move on. And it's just going to display the fact that the constructor has been called for our object creation, and then it's going to continue on with the remainder lines of code that we've already looked at before. Let's go ahead and stop our application now. So a constructor is simple as that. It's just code that we want to run as soon as a new instance of our object is created. It's just a special method. So let's continue on when we're talking about methods and talk about how to overload a method. And the concept of overloading is a little bit more difficult. I might be overloading you with too much information right now, and that's not the overloading we're going to be talking about. In object-oriented programming terms, overloading means that we create two methods with the exact same name. And the only difference is what is called the method signature, or rather the number of arguments, the number of parameters that the method accepts. So let me show you an example of this, and I'll explain why you'd want to do this. Now you can overload any method. I'm just going to happen to overload the constructor. We could overload the derive method that we created a few moments ago, but I'm just going to use the constructor and then show you why it's useful. Okay, so what have we done here? We've created another method called car. In this case, you can see that we're passing in 3 parameters: the make, the model, and the elapsed mileage. It's exactly the same, except that this particular instance, our first constructor, didn't accept any arguments, any parameters, and this version of our method accepts 3 parameters. Now what are we going to do with that? Instead of setting the make to default, model to default, and elapsed mileage to 0, instead we're going to set them to these initial values that we pass in at the time our car object is created, an instance is created. So let's go back over here to our Form 1 code, and let's comment out some of these things. Let's comment that out, let's comment that out, and come down here, and we're going to type in car, my car2. So we're creating a new instance, a second instance of our car object, and this time we'll do something like this, car. Now notice whenever I use the open parenthesis that I get a little IntelliSense that tells us that there's 2 versions of this method that we can select from. The first version doesn't accept any parameters. You can see the open and the close parentheses. If I use the down arrow on my keyboard or use my mouse to click the up or down arrows, I can see the second version of this method that's available that accepts the make, the model, and the elapsed mileage. So in this case, I can put in Ford Mustang, and we'll just make it 100,000 miles. Okay, so what I've been able to do is create a new instance of the car object called mycar2, and then initialize its values by using an overloaded constructor to supply the default values for my object. So now you might be asking yourself the question, why are you overloading? Well, overloading is something that you do as a convenience. In this case, instead of using the default constructor to initialize the values to some default, perhaps I want to have the option to specify the values that are going to be used for the initialization of the properties. I can pass these in as parameters and have them set at the point the object is first created in memory. So when you think of overloading methods, any type of method, whether it's a method you create or a constructor, think of the convenience of having multiple ways of calling the method from the part of your code that consumes your object. Okay, before we move on too far, I just want to make a couple of observations. In the previous 5 lessons, we pretty much coded everything as a result of the button 1 click event, and that was fine. We didn't have to think too hard about where to place the code or anything like that, but it really limited our applications that we could build. But now, notice that methods, event handlers, constructors, and properties all contain, or rather define, code blocks. And a class, like our car class or our Form 1 class, also defines a code block, and it's a container for these kinds of things, properties, methods, event handlers, and things of that nature. And you can't just have a method or a property floating outside of a class. There's a certain hierarchy. We can't just take the button 1 click event and move it outside of this class area, outside into this just white space over here at the very top. There's a certain hierarchy that we have to follow. All of these structures, methods, properties, and so on only make sense when defined in the context of a class. Now additionally, a class can reference another class, as long as it somehow obtains a reference to that other class. It can create a new instance of the class, or it can receive a reference to an existing object through a property or method parameter, or whatever the case might be. Now, as you can see in our examples, our button 1 click event handler, which is simply a method inside of our Form 1 class, creates a reference to the car class. It actually now creates two references to our car class. And our car class, in turn, could create a reference to another class in our application. So there's no limit to that. And I also want to introduce another little gotcha that you might run into. And this might be a little complex, so you might want to really listen closely. Do you ever wonder why we never had to create an instance of the MessageBox class before using the MessageBox all over the place? Well, the reason is because the MessageBox class has been defined with the static keyword, which means that it's not necessary to create an instance of the class before using it. Now, that's different than what we've been doing up to this point, where we had to create an instance of the car class, for example, before we could use it. Now, the same is true whenever we use the int.parse statement several lessons ago, and I said just accept it at face value. Well, we never created an instance of this object called int. When you define a class with the static keyword, it becomes different from a class that requires an instance to be used. We could, for example, change our car class to be a static class, and if we did that, we wouldn't have to use the new keyword whenever we wanted to reference the car. It would just always be available to use anytime we wanted to. Now, the problem with that is that it wouldn't make any sense for the way that we're trying to use the class right now. What we could do is create a new class, and we'll call that the distance processor class. And the purpose of that class would be to calculate the distances from one town to another and how much gas would be required and so on. Now, in that case, it might make more sense to create it as a static class, since it's more of a utility class than a class that deals with domain type information like car and state and city and things of that nature. Okay, so if that didn't make a whole lot of sense, don't worry. Just keep that distinction in the back of your mind, that some classes can be defined in such a way that it doesn't require an instance of them to be created first. And those are referred to as static classes. Now let's take a brief time out and talk about partial classes, which is a slightly more advanced topic, but I've been putting it off until we had a chance to talk about classes and objects. Partial classes are new to CSharp 2.0, which is the version of C# you're going to be working with whenever you're working with Visual C# 2005 Express Edition. So you might be the first on your block to actually learn about this. A partial class allows you to define a single class in more than one spot. In other words, you can break up a code block that defines a class into more than one file, putting, for example, half the code in one file and half the code that belongs to the class in another file. Now again, since you're just starting out, it might not make a lot of sense why on earth you'd want to do such a thing, but I assure you that this is actually a pretty nice enhancement to C#. Now here's one place that it makes a lot of sense. Up to now, when we change the properties and controls on our form designer, and I've been saying that behind the scenes the IDE is writing code for you, but I never really showed you where that code is being written. So let's look into this a little bit more closely. First of all, notice that in the Form 1 definition, we see this word partial, public partial class Form 1. Now if I use the Solution Explorer here, and I drill down into Form 1, notice that there is another file that's kind of hidden underneath the form1.cs file, and that's the form1.designer.cs. I happen to have it open already in a tab. This file contains a lot of the code that's written automatically by the Properties window, or written by the form designer, or anything that writes code for you. It's typically written into this file. Now, notice that it too shares this keyword partial before the term class form 1, before we define the class. So when you combine this file with this file, you get the total picture of what the class form 1 actually contains. Let's go back to our form1.designer.cs. And here, take a look at this region that says Windows Form Designer Generated Code. I'm going to open up this region, and there's a bunch of code that we never knew existed, but is completely necessary. Like, for example, take a look at button 1 and all the properties of button 1 that are set. First of all, it sets the font to Arial, as you can see here. I'm going to scroll over a little bit. It sets the location of the font to 192 X by 199 Y, so it sets the X and Y coordinates, sets the name, sets the size of the button to 73 wide, 23 tall, the tab index, the text that we changed to OK, and it even adds the event handler, button one click, so that whenever the click event is called on the button, that event handler is called. And that's a little bit advanced, but you can see that all this code for button 2 and form 1 and so on is written and hidden for us in this partial class, specifically in that region, Windows Form Generated Code. Now we could modify the values that are in here, but we take the risk of breaking something in the designer. So at this point in your experience, I'd recommend that you look but don't touch. Now we can create partial classes too, and all you need to do is use the partial keyword before defining the class. Now watch, and I'm going to do this and put our drive method in it. So I'm going to add a new class, and I'm just going to select from the little menu here, and I'm going to call this partial class. You can call it anything you want to. And we're going to change the default name that the template gives us to car, and we're going to use the partial keyword before it. Now let's go back to our car.cs file, and what we'll do is take our method, we're going to cut it from here, and we will paste it into our new partial class.cs. And let's go back to the car class, and we need to make one more modification. That's to go and change this also to partial class car. Okay, so all we've done is just split our car class into two different files. And we can go here, back to our form 1, and let us comment that out and rerun our application. Hopefully we haven't done anything that breaks things. And let's get rid of our breakpoint by just clicking on the breakpoint and then selecting run again. And we get our constructor call, and then our drive method was called, returning to us the value Chicago just like it did before. So that's how you create a partial class in C#. Now, why do you need partial classes? Well, in all honesty, you really don't. I just wanted you to be aware of what a partial class was so you could see the relationship of the form1.designer.cs in regards to the form1.cs and where all that code is written that I've been promising you all these lessons that it actually was writing code for you and it was just hiding it from you. So you can use partial classes as a way of organizing your code. But at this point in your career, don't really worry about it. Just want to make you aware of it. Let's now talk about the words public and private that keep popping up in our examples. Public and private are types of modifiers, and a modifier changes the visibility of that particular code block. And you can apply public or private to class definitions, to the definition of a property, of a field, of a method, and so on. Now, in the context of a class, it refers to something that we really haven't talked about yet in terms of code libraries. So let's just save that discussion for some other time, but let's focus right now on the use of modifiers in terms of a class's properties, fields, and methods. When we design a class, we're going to want certain things to be visible and certain things to be hidden to the code that uses the instance of that class. Those things that are marked with the keyword private will be things that are not accessible by the code that creates an instance of our class. In the case of a field, the only way that the code can retrieve and use the value is by using the associated public property. We've marked the property as public. It can be accessed by the other code. The field is marked as private. We don't want the user to be able to access the field directly. We'll talk about why that is in just a moment. So let's do this. Let's go back to our code examples here, and let's play around with public and private and see what changes are made within our application. Let's go back to our car.cs file, and you'll notice here that we've used the keyword private for the fields that we have listed here. I'm using the keyword public for the properties that we have listed below that. That's because I want my properties to be visible by the code that has created an instance of my class. In other words, I want my button one click event where I created an instance of my car class to be able to set and retrieve the properties that I've defined. It wouldn't make any sense to mark these properties as private. They'd be basically unusable. But let's do this just for fun. Let's mark this as public. And then, whoops, let's close that and go over here to form1.cs. And now, whenever I go to my IntelliSense, my car dot, and notice that underscore make is now visible. Let's change the visibility back to private. And notice that it's gone now in my IntelliSense. And even if I tried to do this, and if I tried to run the application, there would be a problem. Car is inaccessible due to its protection level. It's protected by the keyword private. Okay, so we'll just eliminate that. We can also try to make a property private. And in doing so, we get the same error. Make is inaccessible due to its protection level. Let's make that back to public. Okay. So the real question is not the how, which we've just seen how to change back and forth and what the impact is on IntelliSense, but the question is why. You might be wondering why there is this separation that we've made between the storage of a given value in a field with the process of storing the value. In other words, why separate fields from properties? Why not just make the fields all public? And because essentially all we're doing here is allowing these properties to simply return the value and set the value. We haven't done anything special inside of the get and set statements. Now, if you're wondering this, you're on the right track. Good job. The reason for the separation is because there is a concept in object-oriented programming called encapsulation. Think about a remote control for your television for a moment. When you want to change a channel, you can use the channel up or channel down button, and it's going to magically move to the next channel on the television set. Now, you really don't want to know how it works. You don't need to see the underlying circuitry that determines the current channel, and then it sends the signal to the television to change the channel based on that. You just want to use a friendly interface, a single button, and let the complexity be hidden beneath the remote control's plastic exterior. When you're creating classes, you're going to want to keep the complexity of how the class works hidden from the code that wants to create and use an instance of that class in order to accomplish something in an application. So there are some things that you want to keep private and some things that you want to make public. To extend our analogy, you want to provide just a couple of friendly channel up and channel down buttons and prevent the consumer of your class from having to worry about how it works. And this is sometimes referred to as black box programming. The thought is that a class should be considered a black box that just works. Now, there are some practical reasons for this. Perhaps you want to filter out values for your properties that are just ridiculous, and they would potentially crash the application. Or perhaps there are other dependencies between the properties, and by allowing the properties to be set in the wrong order, or allowing some properties to be set and others not set, maybe that would create a problem within your application. So as you're starting out, these might not seem like good reasons to go to all the extra work to create properties, but I assure you that the principle of encapsulation is very important. Now let's extend our example so that you can see how we can modify the make property that we have here and only accept certain values that our application can understand, instead of allowing just any random string to be entered in this particular property. So what we'll do is first of all comment this out. And here I'm going to paste some code for our new make property. And you can see here that our get pretty much stays the same. However, we have changed the way the set works. Now realize that this if statement is a little bit hairy, so let's walk through it just a little bit here so we can completely understand what's going on. We have our selection statement. If value is not equal to Oldsmobile, and, where we have that double ampersand sign there, the value is not equal to Chevrolet. If those two conditions are true, if both of them are true, then perform that first code block. Underscore make equals an empty string. If either of those are not true, so in other words, if it is equal to Oldsmobile or if it is equal to Chevrolet, then perform the second code block underneath the else statement, where underscore make equals to the value. Okay, so in this way we're able to control what is being passed in to set our make statement to. So if it was set to Ford or something else, we would reject those values and just set the make equal to an empty string. Because for our purposes, we're not expecting to see the word Ford or any other string other than Oldsmobile or Chevrolet to be passed in. Again, this is a very rudimentary example, but just understand that we are controlling the way that other code is setting the value of the make property by taking control of the set statement. So that's a pretty thorough explanation of the how and the why behind adjusting the visibility for your fields and properties. Now, methods can also be marked with the visibility modifier of public or private. Now, when methods are public, they're callable from the code that holds a reference to an instance of your class, just like properties are. When methods are marked as private, however, they're usually considered what are called helper methods, or rather methods that perform some small part of the overall function of the public method in your class. Now, they can be used to break down the function of one big, gigantic method into smaller, bite-sized methods. Now, this makes them more maintainable and understandable within your application. Some people have suggested that no method should be more than a dozen or 24 lines of code for this very reason. Now, when you're first starting out, don't worry about this too much. Over time, you're going to start seeing ways to optimize your code, make it smaller, more compact, more understandable. But nobody would expect you at this point to remember all this stuff. So just keep in mind that what we talked about in the previous video, that there is no one right way to write code. Some ways might be more comfortable, some ways might be more expedient, some ways might be more elegant, but they all have their advantages and disadvantages. So hopefully all this object-oriented stuff is starting to make some sense. If not, just keep watching, and perhaps whenever you're watching this video a second time, give it a couple of days to sink in before you watch it again. Then try some of the examples that we're doing here on your own with your own version of Visual C# 2005 Express Edition. Now, when I was first getting started, this was pretty intimidating stuff, but the more I worked with it, the more that it made sense. So don't feel bad if you're feeling overwhelmed right now. Object-oriented programming challenges everybody at first. It's tough stuff, but eventually you're going to get it, and it'll be second nature to you. So now with that word of encouragement, let's move on to another pretty complicated idea. We said just a moment ago that encapsulation is one of the major tenets of object-oriented programming. And now we're going to talk about another tenet called inheritance. And the idea is that whenever you're creating classes, like our car class, for example, you may run into situations where you need a more specialized version of the class. Let's say, for example, you need a minivan class. Now, a minivan is a lot like a car. Many of the properties of the car can be used to also define a minivan, and perhaps there's a few extra properties that could be added to a minivan class for special things like the number of kids that you can fit into it, and you know how many soccer games you can attend with it, and so on. And while the drive method still applies, perhaps the way that method, the drive method, is implemented, the code that's inside of that method's code block should be slightly different because it's a minivan. So what we could do is we could just create a new class called the minivan class, and then copy and paste all of the code from the car class and put it in our new minivan class. Now, if we needed to fix a problem, however, that we have with the car class, then we need to be fixing it in two spots, the car class and now the minivan class too. That's not a huge problem until we start adding the truck class and the sports car class and so on. Once you start adding a bunch of specialized classes that are all created based on the original car class, you're going to start running into this problem of managing all of this code. So the question is there a better way to do this? And of course there is, using inheritance. We can just inherit from the car class, which we're going to call a base class, since it is the parent to the other more specialized versions of the car class, like the minivan, the truck, and the sports car, and so on. So let's do this. We're going to right-click, select Add New Class, and we're going to call this minivan. And so now we have our new minivan class available. And now I'm going to paste some code in our minivan class. Okay, so as you can see, the first thing that I've done is I've used some special nomenclature here. I use a colon, and then I refer to lesson06.car. Lesson 06 is our namespace, and we'll talk about namespaces again in the next video. But what we're actually doing is saying that we are going to derive our minivan class from our car class. So car class will be our base class, and then minivan will be our derived class, or our child class. Okay? Then you can see here, what is this? This is a constructor for the minivan class. And notice that nowhere here have I defined a field called _make. That's because we're relying on the car class to supply the fields, the properties, and the methods. In fact, we wouldn't have to write any code within this class, and we'd get all the functionality automatically from the car class. But we're looking to extend and specialize the minivan class specifically for minivan functionality. So, as you can see here, we've added a field called passengers, and we've added a public property called passengers to allow us to get and set that value. Then we have overridden the drive method in order to kind of create our own specialized version of drive based on the fact that we're dealing with a minivan as opposed to a car. So in order to override our drive method, we use the keyword new. In this context, it means that we are redefining how the drive method will work. And then you can see that we have some different functionality. We're still using a switch statement, but we've looked for different information like Chrysler and Dodge and returning Indianapolis, Cleveland, and so on. Now, let's go to our Form 1. And let's comment out some stuff here. And I'm going to paste in our declaration for my minivan equal to new minivan. And then I'm going to paste in some more code. And again, I just want to emphasize that we didn't have to do anything to define in our minivan class the make property, the model property, the elapsed mileage, yet we're still able to use those because the minivan class inherits from car. We're also using the drive method like we used before, and we're using our new passenger method that we just created that specializes this class to become a minivan as opposed to just a regular car. Now what we can also do is this, and it's pretty cool, just to prove to you that the minivan is really still a car at heart. And that's this. We can change this to car, my minivan equals new minivan. And this would still work. So we're able to use the base class to define the type of object that we're creating, but then specialize it whenever we're creating a new instance. So that's just a little bit to make your head spin. Don't worry about that too much. Just understand that the concept of inheritance, which is used a lot in the .NET framework, means that you can borrow from the functionality of an existing class and make a specialized version of it. There's a lot more to inheritance, and we've only scratched the surface, but you can see how the basics of inheritance work from this really simple example. So we're coming to the close of this video, and I decided to wait until now to point out some of the benefits of object-oriented programming because I'm sure that you're probably skeptical up to this point, having introduced so much new functionality so early into this process. And as I said earlier, some of the benefits may not be very obvious at first. After all, it seems like it would make your life a lot more complicated. But as you begin to develop applications, you're going to see that approaching application development using object-oriented principles can actually make things a lot easier. First of all, the benefit begins whenever you're designing your application. Object-oriented programming actually starts with object-oriented analysis and design, also referred to as OOA&D. And these are concepts that provide a logical way of breaking down a big problem into smaller, easy-to-digest, bite-sized pieces. It's easy to think of the major classes your application might need, and then start adding the properties and methods to each of those classes, charting the interaction between the classes, and so on. There's a whole set of methodologies that are created by various people to help you through this process, but that's a little bit outside the scope of this series of lessons, and quite frankly, that's a little too early for you to worry about. Just thinking in terms of objects sometimes makes conceptualizing how to construct a program a little bit easier. Secondly, if you keep everything related to a car, in this instance, in just one class, it makes it easy to change how your application functions by just changing the code in one spot. Now let's assume that you wrote your application in a very haphazard way. You've got a lot of places in the application that allow the user to modify car data. Now, your boss comes up to you a month later and says that, hey, we need to change the way the application modifies the car data. Now, you've got the unenviable task of searching through all the code, through dozens of forms and files where the car data might be modified. Now, once you find that code, you need to carefully change it, hoping that you didn't miss anything or forget something, because if you miss something, some code that needs to be changed, you've really got problems. You've got a lot of bugs, and it's going to take a long time to debug it. So at the very least, you've created a lot of extra work for yourself. And you caused your application to be larger than necessary because you've got the same code in lots of different spots. And you made it more difficult to update because you have to look in so many different places in order to change things. But if you were to take a more object-oriented approach, you would have just changed the method in the car class that modifies the data, and then you're finished. If you introduced a bug, you've isolated it to a single spot in code. It's not spread all throughout your entire application. Which really brings us to the third benefit. By encapsulating functionality in your class, the code that creates and uses an instance of your class might not have to be changed, even though you update how your class operates internally. So in this particular case, if we were to just use a more object-oriented approach, and we have a single method that updates the car data, we might not have to change any other part of our code, not the code that calls it, or retrieves values from it. We are able to, again, use more a black box programming style where we're able to hide that complexity from the end user. In this case, the end user would be the code that calls your class and creates an instance of it and uses it. And that code wouldn't be impacted at all. And at least that's the best case scenario. And then the fourth benefit that we're going to discuss for right now is that you have the potential benefit of reusability. Since your car class is modular and all the code related to cars in a single class, you could copy that class file and use it in a different project. You wouldn't need to rewrite any code in order to gain all the benefit of your car class. You've already worked out all the bugs, so that saves you a lot of time in terms of designing and developing and debugging the new code. So reusability is something that we can always aspire to whenever we're developing our applications. And there's a lot more that I could talk about, but I suspect that your head might be spinning at this point. But I recommend two things. First of all, as I suggested just a moment ago, watch this video again and follow along with the examples. Pause the video when you need to try something on your own, and really take the time to work through some of these ideas. And also I recommend taking a look at the additional readings that I put together in the accompanying document. Also, search online for more information about some of this stuff. The quicker you get all this under your belt, the quicker you'll be on your way to really harnessing the power of .NET. I encourage you to not make it harder than it really is. Don't feel like you've got to understand all this stuff 100% before you can be productive. That's not true. Like I said at the outset, it might take months before you can really master some of these concepts, before you see the value in using this approach of object-oriented programming in building your applications. This is really just the first step in a journey, so by all means don't get discouraged. Just keep plugging away, and before you know it, everything is going to start making sense, and you'll know everything that you need to know. Now, if you enjoyed watching this video, please visit www.learnvisualstudio.net to download and watch over 400 videos just like this one, aimed at all skill levels on many different topics related to C#, Visual Basic.net, ASP.NET, and more. Thank you.